Hello everyone. Today we're diving into the world of database replication. Specifically, we will be focusing on master-slave and master-master replication patterns. Database replication is a crucial concept for ensuring data availability, fault tolerance, and improved performance in many applications. So, what exactly is database replication? In simple terms, it is the process of copying and maintaining database objects across multiple database servers. This ensures data availability, which means your data is accessible even if one server fails. It also provides fault tolerance, so your system can continue running smoothly despite any issues. And finally, it contributes to improved performance by distributing the load across multiple servers. Let's start with master-slave replication. In this pattern, we have one master database server and one or more slave database servers. The master server handles all write operations, meaning any changes to the data are made here. These changes are then copied to the slave servers. The slave servers handle read operations such as querying the data. So the flow of data is from the master server to the slave server. Here is the sample code to show the implementation of master-slave configuration. This code block shows a basic setup for a master-slave configuration. The function setup_master_slave configures the master database for replication. It sets parameters like server_ID, log_bin, and binlog_format to ensure proper replication. Finally, the configure replication function starts the replication process. Next, we have master-master replication. In this pattern, we have two or more master database servers. Each master server can handle both read and write operations. Changes made on one master server are replicated to the other master servers. This creates a bidirectional replication setup, where data flows between all master servers. Both database server can be called active node. Here is the sample code for implementing the master-master replication. This code sets up a master-master configuration where both nodes act as masters. The setup_master_master function configures each node with a unique server_ID, auto_increment_increment, and auto_increment_offset to prevent conflicts. The configure bidirectional function then ensures that changes are synchronized between the nodes. Now let's compare these two replication patterns. In master-slave replication, there is a single write node which is the master and multiple read replicas which are the slaves, providing high read scalability. On the other hand, in master-master replication, there are multiple write nodes with bidirectional replication, resulting in high availability. Before implementing database replication, there are a few key considerations to keep in mind. First, performance. Replication can impact latency, so you need to consider the network bandwidth and potential replication lag. Second, consistency. Data conflicts can occur, especially in master-master replication, so you need to think about eventual consistency and conflict resolution strategies. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.